Chapter 10 Review Estimating with Confidence.
For a confidence interval in 10.1, you need to use high confidence and small margin of error, which is very ideal. The margin of error equation is z star standard deviation divided by the square root of n. And how to reduce the margin of error, there's three simple things that you can do. You can lower c, which lowers z star, increase n, and reduce the standard deviation. For choosing a sample size, in order to find your desired margin of error, you do n equals z star times standard deviation over the margin of error all squared.
For estimating a population mean, use the sample standard deviation is s instead of the theta. Standard error is when the standard deviation is estimated from the data. So it's s divided by the square root of n. T-distribution occurs when we use s in place of theta. Standard deviation of the population is unknown. K is the degrees of freedom, so n minus 1 in this case. The mean is always 0. And T equals x bar minus mu divided by s over the square root of n. Then use TCDF on the calculator.
For 10.3, it was estimating a population proportion. And the equation for p hat, which is the population proportion variable, you do x over n, which is equal to the number of successes over the number of observations. And so mu of p hat, which is the mean of p hat, is just equal to p, which is the true proportion. And standard deviation of p hat equals square root of p times 1 minus p, which is success times failure over n. And a level c, which is confidence interval for p, is estimate plus or minus margin of error. P hat plus or minus z star square root p hat 1 minus p hat over n, which is the same deal as with the standard deviation, where it's the success minus the failure over n. And the standard error of p hat is standard error p hat equal to square root p times 1 minus p hat over n. And for choosing your sample size, the margin of error is equal to z star times all square root p times 1 minus p hat over n. And since we don't know n, we can't calculate p hat, so we use p star, which either use info given in problem to estimate p star or use p star equals 0.5 just as a baseline number. And margin of error equals z star all square root p star times 1 minus p star over n. So all of these equations seem to have a common thread of the p, 1 minus p, but it just varies depending on which p you're trying to find.
So this is a refresher on the inference procedures for intervals. So the first step is you always state the name of the interval and identify the parameter in the population of interest. So for z, t, and proportions, you'll always state one sample, what the interval for population mean at the confidence or the c percent, so the confidence percent. The second step is check that all assumptions are met. So data from the SRS, is the population normal? So there's a few steps for that depending on what you're using. And then if the observations are independent. So the third step is construct a confidence interval and give the formula, which were all in the previous 3 slides, the formulas. And then fourth is interpret in context. So you'll always state that we are C% confident that the true mean / true proportion of, and then you'll state the interval that it's on.
Quiz time. So we have 5 questions, nice multiple choice practice coming up. So we'll give you guys a few minutes to do that on your own, and then we'll go over the answers.
You probably want to pause the video.
Yeah, that would be good. All right, so the multiple choice answer key. Number 1 was A, 2 was A, 3 was C, 4 was D, and 5 was C. Hopefully you guys did well.
Here's the open response.
Once again, you might want to pause the video.
Yeah, here's the answer key.
All right, that's it. I hope you enjoyed our video.